it's very impressive, his bio, from Carlos. I'm going to start saying that he is a founder and general director since 2015 for TCC, his Technology Creative Core LLC, his own company. And he is dedicated primarily to pioneering advancements in 3D printers and 3D printing technologies. How about that? Develop telemedicine systems to enhance remote healthcare capabilities. Design automation solutions for hydroponic greenhouses. I don't know exactly what it is, Oscar, you're going to tell us. Implemented artificial intelligence-based testing and automated equipment. He in El Paso. And
he's crazy.
I'm going to jump. Yeah, I'm going to jump to another one because his bio is impressive, really. The next one is from 1997 to 2009, working for Zilog as a program manager and design manager, especially directed microprocessor and microcontroller architecture development. How about that? And for Philips, development engineer manager from 1996 to 1997, focused on optomagnetic components and remote control design and development. How about that? Also working for AMP, engineering director, directed the development of industrial automated systems. And also working for Chloride Power Electronics, IBM, joint venture, design and development manager. IBM mainframes and PC power supplies. How about that? And another one, in Ampex, test engineer and design engineering manager from 1974 to 1980. That means something else. Design professional, multi-channel tape recorders and studio video recorders. Wow, he's a genius. Education, Instituto Tecnológico Regional de Chihuahua in engineering electronics and industrial from 1969 to 1974. Automatic control systems, digital systems, and informatics. And there's many achievements, okay, that I couldn't have the time to tell them all, but I hope Oscar is going to have the opportunity during his presentation to tell us some of the major achievements, okay? So please welcome Oscar Miramontes.
Okay, thank you, Orfeo. Well, pretty much like what, 50 years in the road, doing all kind of things in many places in the world. In most of my life, I have been working designing products, okay, or managing groups, designing different products in here in the US, Mexico, India, China, Europe. And also, one time I was managing about 5 different design centers in the world. I was getting crazy, okay, so I kind of slowed down and started doing something. But all distributed came from Europe, and Belgium, and London, and India, and Bangalore, and the US, and California, and then Mexico, Juarez. So anyway, yes, my life has been designing products. So when Orfil invited me to, do this, I said, well, it would be good to talk about what it takes to develop or create a product. And so I prepared this list. Here's the outline. I'm gonna go in deep into every one of these areas. But there is, I was impressed with 2 companies I worked with. Was one IBM that they call this product creation procedure or process, and they call it PPQP. Okay, product was it was product quality process, and I'm going to forget what was second P. Product process quality process. I think that was it. Okay. Anyway, IBM very much was very concerned about the quality all the way from the conception of a product, okay, or even from the marketing side. Yeah, and then I try to combine both of them and try to extract the best of those two big systems to develop process. The product creation process, the name comes from more from Philips. So Philips had this product creation process, which involved everything, okay, from the conception of the product. One of the big projects I worked was in the development of the laser, and actually the DVD players, okay? Philips and Sony were the only two companies in the world that had the optical pickup unit for lasers. And we went into all the marketing studies. Actually, I had a chance to go in several parts of the world, talking to retailers to understand what were the impression or the needs of having a DVD player, etc. So it was very interesting, and that's why I added this first part, okay, that is the marketing side. It's not really marketing, not necessarily it's part of the creation process, okay, but it's a kind of a necessary evil there.
Hey, I'm sorry, Oscar. Will you share your screen?
Oh, sorry.
Thank you.
Yeah, yeah. Okay.
Yeah,
So,
now we can see it.
okay, sorry. So yeah, so this is the marketing part. Okay, this process, what I put is the most, I may say, common and popular sections for almost every company in the world. Obviously, there are a lot of changes.
Yeah.
Many companies, they have some weird processes. Some of them are more organized, some are more professional, some are more artistic, etc. Okay, but pretty much all these parts are what integrates the creation of a product. The marketing obviously is the part where the product is found, defined, okay, and discussed. And then after marketing finds something that they like and process and digest, they turn it into the process really, that the first phase is a feasibility phase. And pretty much here is when everything is set to say if this product is feasible, okay? It's something from this planet, from humans, etc. Yes. And if this is the case, we're going to see some details here, we're going to a design phase. So pretty much design phase usually receives specifications from some place, from some other company, or maybe from the marketing team usually receives some requirements, okay? So marketing provides requirements, provide the artistic drawings, the conceptual physical product, etc. And all that is feed into the feasibility phase. Once it's feasible, it goes into the design phase. The design phase pretty much starts from specs and requirements, and basically start creating the product, okay, giving the form that was in paper, in the ideas of some people, and make it then tangible, real. After the product is designed, okay, we have to do some prototypes, okay, to see if the thing works or not. So we go to the design phase, to the development phase. Development phase typically is divided in two sections. What is the alpha prototypes and the beta prototypes? And the alpha prototypes, sometimes they are pretty much done in the feasible phase, okay, the feasibility phase. Usually to prove that product or test if a product is feasible, we have to build prototypes here, okay? And they are kind of big monsters of things that the only thing is to prove the concept. And then everything is on the previous phases is sent to the next phase. So design, in many cases, may receive kind of a alpha prototype, okay, kind of a little monster that is functional and gives some big idea what is the final product, and or just the specifications and the requirements. But at the end, the design phase has to pretty much design the product based on those specifications, and then transfer that design with all the documentation, with all the different test processes and evaluation processes to the development phase. Development phase, if nothing was developed as a prototype in the previous phases, they designed the first alpha prototype. Usually it's a prototype that not necessarily is the same as the final product, okay? Something that they put all kind of things together to prove the concept of the functionality. And even doesn't have to physically look like the final product, but anyway, the better or the most it looks like the final product, the better. So from there it goes to the second phase, which is the beta products, beta prototypes. The idea is that it's a prototype that will be same as it will be the end product. Sometimes there are some differences because materials are not available or some other things. But anyway, it should have functionally same that as the final product and hopefully cosmetically and mechanically, physically same as the final product. So here the prototypes are used for just that purpose, to check if the product works, if the product meets the requirements, if the product meets the specifications. Once that's done, obviously all the documentation is already here, and that is transferred to a pre-production unit. Pre-production could be in the actual manufacturing facility, or could be in a special facility where, depends a lot on the product, okay? That they run X number of products to say, yes, it works. And then also in the pre-production area, most of the, I may say, the process where this product is gonna run in a higher volume has been is designed. Okay, and when you go to mass production, typically it comes with everything, to all the packages. Okay, all the documentation of the product, the documentation of the, I mean documentation of the tests, documentation of the what the process or critical part of the process needs to be integrated. Now, sometimes the way we are today, let's say the product is designed in California or some other place in the world, and it goes to manufacture in Mexico. There are many things that has to be adapted and built in Mexico or in the country where it's going to be manufactured. So, okay, so very much that's the outline. Okay, looking from 30,000 feet, and the events that happened, okay, in the different areas is. Marketing, typically, we want to face many things, okay? Is this a new product? Or if it's a new product, okay, it's a product from OEM customer product line, meaning they did not match in marketing, they just took from the OEM customer, and they transfer here for going to other phases.
Oscar, can you make the screen a little bigger?
Yeah, let me see.
Because it's not easy to read it.
Okay, let me find the little things that.
It's very clear for me, Oscar.
Yeah. Okay. Let me.
Okay.
How about that?
Yeah. It's good.
Okay.
Yeah. Thank you.
So marketing very much is to provide this is a new product. It's a product from an OEM that already is making that, and they need to change things or whatever. Is this a new module from a current product line? It's a new product, new invention. So this was invented, and only this team knows what it is. But marketing said, yes, we have this the future for this project. New product, not in product line. Sorry about the. So let's say some customers, they have like TV companies, they have product lines of TVs, okay? But now this is a new product that was part of the TV product line, and it's just some different look, other functionality, etc. It's not something that starts from scratch, it starts from something that companies already have. Or a new product from product line, okay? So in this case, this is for the product line. The other is not product line. Sorry, the not product line meaning it's a new product, or it's not product line for the previous for this product. So this company creates a new product line. Let's say this company is going to be now doing DVD players. It was not doing before. So anyway, so marketing pretty much takes care of identifying all these things pass downstream, and then create basically, provide potential competitor data. Typically, every company, when you're gonna do a product, you're gonna take samples from every piece of competition. So if it's a TV, take all the TVs from the competition and see what they have. Obviously, that also helps that not go and infringe patents or that kind of stuff. Also, marketing basically create or write the requirements. So marketing define, the animal has to be like this, look like this, etc. And then provide all the collateral data, meaning the prints, drawings, etc. And then, once all that thing's on, it's been transferred to the organization management, and the organization management start the feasibility phase. Okay, so here, basically, because this is ASQ, I put it this, one of the very first things is to know for our product is, what sort of quality this product has to be, subject to.
Thank you, Oscar.
Yeah, I mean, somebody has to say, this is a quality that should run in a Six Sigma process. Okay, it's gonna cost more, but anyway, we'll run like that. But anyway, so yes, first thing the feasibility is that, maybe the customer is asking for a Six Sigma, a product from a Six Sigma process, and the feasibility phase, company may say, well, no, we cannot do it. But it says, yes, we can do it, or we cannot, or we're not doing that, but we can adapt our processes to do that. Okay, great. Then we need to here define, what type of certainties and uncertainties are for this product. Is really something from another world that we may have some more problems, etc. Well, this phase has to clean this thing. Yes, it's certain that we can go ahead and do this product. Then, some preliminary drawings, creative preliminary drawings if are required, because those drawings help everybody in the team that is working in this feasibility phase. Here we had to define if proof of concept, prototyping required. So we cannot wait until the development phase to define that, it's not a proof of concept, So the thing didn't work, or it's not possible to work anywhere on the world. So this phase may do this preliminary. Proof of concept, and so usually here somebody may prototypes to be sure that this kind of work with the main concept of the product. Also find if there are specifications available. Some customers may provide specs, some others not. So marketing has to extract everything from customers to create specifications, or within the process here downstream will be created. Finance, obviously, the feasibility has to understand the budget for this project and define if that budget can be get or meet, and somebody has to have money to do this thing. So, and they have to see if the requirements that were provided by the upper layer of the phase is accepted or not. Then, kind of schedule a roadmap. Here we are, everything looks accepted, and when and how the time to do every stone in the roadmap. And technology here is interesting because usually you face that, if it's a technology product, maybe, you have to define if the company has the technology or not. So say, we have the technology, great, keep going. But if we say, well, no, we don't have the technology, management here say, who has that? So somebody has to go and look who has the technology. And they come and say, yes, this company has the technology, how much? So I say, okay, you have to pay this much for this technology. And say, well, okay, we pay it and we get it. Or say, not too expensive, so we'll open a research project, okay? So here we're gonna do an applied research project to do the research on technology and create and acquire the technology, but our own research. Some companies do that, okay, because they say that, yes, somebody has the technology, but it's impossible. Or even the competitors say, yes, I'm going to sell you for 100 times what you're asking for, so you don't get into this thing. So anyway, also, once that's done is human resources. We have the human resources to do this project. Okay? Obviously, here they had to go back and forth into the design managers and say we have this type of human resources, but not only in the technical area. Do we have human resources for the administration, for whatever other activity, okay, that we created for this project? So it's kind of started getting accepting every one of these steps. Materials, what type of materials we want to get? Can we get those materials on time? Maybe you can get the materials, but we'll be ready till next year, so maybe not feasible for this thing. Okay, getting to the legal part. Okay, are we getting into any illegality with this project? Okay, we have doing a 3D marketing. Okay, the marketing started with the 3 dimensions of this thing. Here are the main bullets. Okay, some may not be in order, but very much that's what is in this phase. Also, the risks. I mean, some managers are not aware of risk or don't care about risk, but some others they do. So basically, this phase, everybody has to clean and get say yes, we pass them the risks. They are okay. We can afford those risks. Obviously, there are other things that nobody knows that they were necessary. At the end, okay, if the feasibility is okay, everybody signed, the upper management, the engineering, the technical part, and say, yes, transfer to the design phase, okay? If not, okay, stop for review, because sometimes we have a project, the feasibility was not achieved and not, we couldn't get that. So you have to go back and recycle the whole thing and see what's necessary, or simple cancel the project, okay? To give you an idea, when I work in Philips in the development of the DVDs, and we have a big team, from, I don't know, about 40 people working in this phase. And we went through the whole work for talking to the distributors, reps, everybody to see if everybody wanted to have a DVD player. We found that yes, everybody wants that, and everyone was happy because we meet all the requirements. And then we present this to the board of directors of Philips. And the guy said, yeah, congratulations, it's a great job. But you know what? We don't have the money to do it. So the option from all you are presenting here is that what we are going to do, the only thing that we do well, which is the optical pickup unit. Only Philips and Sony do that, and then we're gonna subcontract the use of that technology. So they found that they will make more money, okay, just contracting or transferring the technology, okay, to other companies, and that's why everybody started making DVD players. So all that can happen here in the first phase. Here are more details, activities, okay, that the project is registered, review of specification if they exist, okay, material resources, pretty much what I described that, financial review, budget, okay, they assign the sales and design tasks. Sales meaning how we're gonna make the divide, okay, of this process. Define the critical path, including the development phase, preliminary design. Sometimes from here we have kind of a preliminary idea, alpha prototype. Okay, so So basically, we have the thing to test the concept, documentations, drawings, bill of materials, preliminary cost and report, final design. I put an asterisk, okay, because nobody do a final design at the first pass. Yeah? Not that I know, nobody that I know. The release of preliminary documentation, not subject to engineering changes, okay? This is still owned by design, but our design development group, so the organization engineering changes still not work here, but we're doing a lot of changes. Documentation for development phase. So that has to be provided here. Service documentation, marketing and sales documentation, prototype transfer, if any, to development phase. It's very likely, or sometimes we prefer that the design engineers make a prototype, like I say, alpha or pre-alpha, and transfer that to development so they don't start from scratch. Otherwise, design has to be jumping into the guys that are doing the development, construction of the prototypes, all that. Then define the design engineering system. Here we had to define how we're going to be standard, meaning that we would transfer the responsibility of engineering changes to the factory. So we have like a sustaining engineering or product engineering, okay? And then review and innovation compilation. Every phase has to have this thing, okay? These companies, they are, let's say, trying to capture everything that could be patentable, okay? Everything that could be no previous art. And usually they capture here and they kind of, it's another kind of layer that is created here for people that comes and do kind of investigation through all the people that is working in this phase to see if there's something that could be patentable, okay? If it's not the case, it's subject for revision. So some patents could pop up from here. So pretty much feasibility in some lines, in some well outlines every other part of critical parts of the process. The official design phase, basically. So one of the first things is to set up the design team. Many companies, they have resources all over the world or the building or whatever. So you have to put the design team and set it up. Design has to accept the specifications and requirements. So design has to say, yeah, I understand what you want, okay? And okay, you give me specifications and yes, so everything looks good and we like it, okay? So we can go ahead with that. Also, after this phase, we have a compilation of innovation. A lot of innovation comes from here, from the design phase. It's on the many things. When designers find how to do things, and those things may be a new art. Okay, so it's no previous art found for that. Okay, so okay, now more detailed activities that we have here. Okay, the pre-registration, HR assignments, reviews the specifications, material resource acquisition and assignments, financial review. Here they have to, I mean, usually in the design phase, we need to see the guys in the feasibility phase did a good job on this thing, okay? Because sometimes they find that it's not possible. Once they digest all these requirements and specifications, well, now these like engineers, the other guys may be some salespeople, accountants, etc., and they come up with the yes, it was financially feasible, but these guys may find that it's not true, something is different. Anyway, and then assign the sales, okay, and design tasks. Pretty much the process for design. Same thing, define the critical path, including the development stage, because design has to kind of control, okay, the flow of the development phase. At the end, we come with a preliminary design. It's all complete or documented. we can come with an alpha prototype that will be passed to the development guys. Development phase maybe accept this or maybe design their own alpha prototype. So as you can see from the feasibility phase, everybody may want to have some kind of a prototype that looks like the product. Okay, then documentation obviously is when design generate all the documentation, drawings, bill of materials. Here it's a preliminary cost report. Why? We have bill of material. We can find out how much this thing is going to cost. Obviously, we have the information here from manufacturing volume. So these guys are assisted by procurement people to get all the different levels of costs, different levels of production level of units made per year. And again, like I mentioned in the outline, is final design. Well, yes, it has to be confirmed and will be confirmed on the development phase. Okay, same thing. Okay, preliminary documentation. Documentation will be available for the development phase. Here, very important. Okay, service documentation. Okay, what type of service manuals we're going to generate for the field? So all the maintenance manuals and other service manuals. Okay, so everything is designed here. Marketing and sales documentation, same thing. Okay, this product is gonna go at show and whatever, and then you need this type of documentation for that show. Usually, this is required by marketing people or by sales people. Then the prototype transfer, if any, to the development phase. So design is design where they created a prototype. Okay, that's gonna go to that little monster go to development. Okay, they don't like it sometimes. Okay, it's better than nothing. So anyway, define engineering change system. Okay, same that vimos in the previous phase. Very much here we have more certainty. What type of and understanding the change process, engineering process of the company. Well, it's decided. It's a standard for the company. If it's something that came from the customer or something special that nobody has done before. So here the idea is that once the product is going to production, who takes care of the engineering changes? Sometimes the engineering changes are so complicated it has to go back all the way to here to design. But usually the local engineers, which are the organization is names like product engineering, other companies sustaining engineering because the engineering is going to sustain the product through its life in production. Okay, they will take care of the product in review. And in many cases, some engineering changes has to roll it all the way back to engineering, to design engineering. Usually that's not good because those guys from design engineering working on the products, they don't remember what this product was. And then at the end, also the compilation of innovation. Like I said, this part is usually the one that generates more patents for the company. Okay. And the development phase, obviously, is the fabrication of prototypes, prototype evaluation in typically 2 rounds in alpha. Maybe that was received from the previous phases, even all the way from the feasibility phase, and beta, okay? Now, what happened with this beta? That's supposed to represent the final product. So is the prototype that is going to be used for certifications, for quality plan. Certifications could be also for like a MTBF evaluation, etc. All the UL, OSHA, FCC, FDA, who knows? Okay, all the certification, this type of prototypes are the ones that are used here. One of the more critical are like FCC, because to comply with some requirement for FCC, okay, you take it to a special lab where they test if they comply with the emissions of radiation. And in many cases, the first time that doesn't happen is to come back to engineering, and they fix things to make it pass. Once it's ready, they pass it to a company that is certified to do certifications. And that's very expensive, so that's why they had to do some preliminary testing and evaluation before that. And then they release this thing under the quality plan that was already agreed in the previous sections. And then they pretty much release all the BOM documentation and the quality plan, say all the information for the MRP. So the buyers know what they have to buy and when, what quantities, etc. Other requirements for production requirement, which is tooling, for instance, what type of tooling is to require. That is in this part practically still mandated by this design team. Okay, development is part of design in some way. So again, the compilation of innovation. Usually this is kind of the last. And the other one is recommendation or definition of test equipment. Sometimes engineering, design engineering can pass to even to manufacturing engineering to design about test equipment, but in many cases it's been designed here. But if it's going to be passed to manufacturing here, they have to sign for that, okay? Because still design is responsible for that product. Okay, so this is a more the granularity of the activities in the development phase. Pretty much what we saw in more detail. All the prototypes, alphas, betas, etc. This thing is something that actually we are looking to implement in the Nodo in Juarez. It's already there, and then the idea is that the Nodo in Juarez will start running projects that will go under this kind of process. So they can create a product that can be, let's say, professionally designed and made and released to manufacturing, same that happens in many companies. Okay, and the other thing is that the students will be involved in this process, so really they can feel and experience here at the school level what happened out there in the field. Okay, cosmetic evaluation is another critical for everybody thinks and make their opinion on this thing, okay? But at the end, somebody has to certify that externally or internally. Okay, the evaluation for the certifications that I just described. The release of BOM and drawings. The BOM is already kind of the final because already it's in a prototype that has been tested and evaluated. Approvals of OEMs and suppliers. So also this, we need to evaluate from when BOMs are releases and buyers start buying things, we have to start evaluating suppliers, okay? And if they come from like a distribution or OEMs. Manufacturing documentation has to be created here and transfer. One thing that we have done in some companies, like MPEX, one of them, was that we pull all the manufacturing engineers to start working in these phases, okay, in the design team. So actually, they come up, or the products comes out with the final documentation for manufacturing, quality, etc. So you don't have to kind of release everything for manufacturing in these guys, or everything is done over there. So everything is done in conjunction between the design guys who knows very well the product and the manufacturing guys who know how to manufacture that. Because some of the surprises in manufacturing is that, okay, nobody understands how to do this thing, and it's a lot of prone to many errors or problems, etc. So it's a good overlap that is good to have to bring the manufacturing engineers or the guys that are going to be responsible for the process, okay, at this phase here. Okay, then pre-production pretty much is done by those same manufacturers many times within the design environment, design and development environment. And so really they replicate the process here and leave it ready for the production phase. Okay, so from here is the transfer, okay, very much to mass production. So when we get here, okay, we have responsibility under the quality organization, sustained engineering or product engineering. So those are the one that they give the support to the product at this stage. And obviously, this is put out the production systems, which is part of this phase now. Quality systems, the application of the quality system was defined previously, so it's applied here. So there are no surprises here. The test systems, same thing, okay? A lot of the test equipment was decided at the design time or recommended, but actually may not be, the equipment used in design time may not be the one for manufacturing. So manufacturing has to decide that here. If additional certifications, okay? Maybe, FDA requirement because this product may have some materials that can cause some problem for people working in the factory. Who knows, okay? And again, do innovation compilation. It could be, or at the manufacturing level, could be a lot of innovation coming out, okay? That could be patentable as well. Okay, so pretty much that's, we're in time. Okay. That's pretty much a quick view of a product creation process. Is there any question?
Hey, Oscar,
Yes,
question.
yes, sir.
Tell us a little bit about the printers that you work on it, the 3D printers. Tell us what steps do you take in these ones?
Okay, 3D printers, we started the company and we started, actually, let's say it was maybe 3 companies here in the United States. One of them, our company, started making these 3D printers, okay, from scratch. And in that time, we follow not exactly this process. We follow, I mean, maybe we went into this outline, okay? We did a lot of marketing study because we needed to understand who were the players here in the United States. There were some initial players in Europe, particularly in the UK. And then what type of technology they were using, materials, etc. So basically, based on the information here in the marketing stage, we pretty much decided to, okay, yes, we can create something maybe same or better than what the Europeans are doing. At that time, was a company in New York, MakerBot, which, yes, they were the first people making the 3D printers. They make a kit, a wooden kit, okay, that you bought and you had to assemble yourself. And so it was okay, it was good. Then for us, because we didn't have enough investment and all that kind of stuff, we said, well, maybe let's do what companies do in this area, okay? Most of the companies working in the creating, let's say, equipment for the maquilas or the local factories was kind of special products, special equipment that was really for manufacturing or test. And so this kind of mimic that. So what we did, we started making 3D printers for the industrial environment, low cost, because our printers started selling maybe in the neighborhood of $3,000 to $5,000, where when the professional industrial printers were in the 10x, okay, like $50,000 in the field. So basically, we did, I think, a relatively good marketing study. We make the feasibility phase, basing, okay, can we make this? We have everything we saw, okay, we have the technology. If not, okay, we had to do some research. Obviously, we didn't have much of the technology. So we had to do a lot of research before we can materialize something. So we did a lot of iterations here. Design phase, we also did a lot of iterations. Built the first concept prototype and didn't work, obviously. And then we had to do a lot of nightmare sessions, okay, with the team. We were a team of 3 people here in the garage of my home. And finally, we found the problem. I remember I went to a trip in Brazil, and when I came and coming back, I got the idea. I said, let's do it this way. So yeah, we did that way and worked. So we prepare some prototypes. We use it ourselves even for because that's what we were training on these machines, that they could build part of their own parts. So a lot of the parts that were released with our printers were made by the same printers. So actually we went into that part, and I really like it. I was like in the market, but the market was very green. Okay, was not. They didn't know about 3D printers. So really, something that we did here in the marketing side, okay, and the feasibility to launch into this adventure here was to say, okay, one of the very first things we had to do is to educate the people in the industry. Because you had to start from the ABC because nobody had heard about 3D printers. And we had a very good sessions like with Delphi in that time, okay, people from Delphi because they were all the even plastic parts that were used for their kit, for their production boards. Pretty much they were machining those with Delrin. And we demonstrated that you can do it better with 3D printing and so on. So but they didn't believe it until we made some samples that they kind of match and say, oh yeah, it works. And but anyway, yes, we pretty much follow this outline. Okay, and the complexity of this outline, when you do those based on the amount of money that is in the game, the type of company, the size of the company, the size of the project. And this was originally a garage project here at home, at my home. So I don't know if that answered your question.
Oscar,
Thank you.
I
Thank
have a
you.
question.
Yes.
We are quality people,
Uh-huh.
and we know that quality mainly is originated in the design phase.
Mm-hmm.
So where the failure mode and effect analysis is taking place in this process that you show.
Mm-hmm. Oh,
Where exactly? Yeah, in which phase?
Okay, in the okay, very much in the feasibility phase is decided if yes, it's feasible to do this project, this product, and here in the design phase, most of these tests will be distributed between design phase and the development phase. Okay, the design phase they don't have the machine, they don't have prototypes yet. Okay, so basically, let's say that this product, you see that you check the specification, it has to be support this type of vibration. Okay, in the design phase, you only have maybe one prototype, so you have to use that. But then for that type of test, when we go into the development phase, and actually pre-production, but development, now you say, well, we have these requirements of MTBF, okay, and that's subject for thermal test, vibration, electromagnetic compliance, etc. So some of the prototypes that are the beta prototypes that are designed here in the development phase are used here or in the pre-production to do the quality requirements tests and evaluations. So
Okay.
I may say they start here in development. At the end, we confirm that in the pre-production. And the reason is sometimes you need several prototypes, several units to do that. Okay. And then obviously once the quality process is defined, okay, you expect that because of the theoretical calculations that are made, there's a military standards that are followed for this kind of stuff, and they say, yeah, mathematically they meet the other requirements. Okay, for instance, some product has to go into initially in the pre-production or production, say, okay, yes, we're gonna this thing are we gonna be subject for I don't know 1 day vibrating and changing temperature cycles and all that kind of stuff. We used to do that for some military products, okay, or very high-end products like the recorders for studios and or tape recorders for mainframes. So some others they are not done at that level. And at the end, what happened? Okay, the way I understand this field of quality in the world is the Chinese, for instance. And I'll give you an example. I was checking a production line for remote controls in China, and I found that I couldn't see where was the quality. We were doing in quality. They were assembling and they were packing and sending, shipping. And I asked, so what happened? Why don't you test this thing or sample it? No, we don't need it. Why not? It's perfect. No. So, hey, who's your customer? It's a Walmart. So, and this is a kind of more, part of the economy of the project. Okay? It was less expensive for Walmart to receive a shipment with, let's say, 10% defective products.
Right.
Then you go and buy them, doesn't work, you go return that and then give you another one.
Right. Right.
So that was the philosophy, okay, of Walmart, more than the Chinese. So in some company like Walmart, they push the Chinese to do this kind of things. So anyway, so when you go all the way from, in particular from the requirements from the customer, they say, oh, it has to meet with this requirement, with this quality requirements, okay, to be, I don't know, 20 Sigma or 6 Sigma, whatever. This is the critical parameters where we're going to evaluate this thing. All that kind of flows from requirements all the way from the customer. Sometimes the customer, they don't know. So basically, you apply your standard system. But quality is expensive. I know that you guys say, no, it's not expensive. Well, yes, it's expensive. But when you go into a product with, let's say, I used to work on some Six Sigma processes with IBM, and I know how expensive those are. Okay? But they were requirement. It was more expensive to have a machine that fell in the mainframe than whatever we were spending here.
Right.
So look, the equilibrium of quality is kind of an art. Okay? But when you don't have other option, you use your standard thing. If your customer is happy with that, that's it. That's good. Now, can you improve? Yes, because you have within your system, you may have improvements that you keep improving. Okay, I see that more in the automobile, in the aerospace industry here in Mexico, where they have teams just dedicated for improvement. And yes, they do some. So that means that never came with all those improvements from design. Okay, this guy found them in production.
Right.
And
Can I ask you a couple of questions, Oscar?
sure.
All right, so two questions, right? The first one is, in your experience, in which of these big categories have you seen the most errors, right? When things go wrong, where do they usually go wrong? Is it marketing or development, design? How would you answer that?
You mean which phase is the one that created most of the problems? Is that?
Yes.
No, the
Marketing?
obviously most of the problems supposed to be detected in the development phase. Okay, so why you don't detect those problems before? Because you're not testing for those. So when you're testing, when you have the good prototypes and good amount of prototypes, where you detecting the majority of the problems. And because you are very close, and even the design engineers are the same doing the development, or they are working in the same room per se, it's a very quick loop to fix them. But yeah, development phase is where most of the problems pop up.
Okay, all right, thank you very much. The other
Makes
question is,
Makes sense.
the other question, Oscar, is how well does this process parallel if we talk about service development, right? Developing a service offering instead of a product. Can we assume that there's going to be a lot of similarity in the process?
When you mean service in the field?
Yeah, offering a service instead of offering a product. I would imagine that we go through similar steps when we're designing a service that we want to offer.
Yeah. Difference on the service is obviously sometimes you don't have any material thing. Yeah? But every product, even if it's software, whatever, follow very much this process. So there are products that are a combination of software and hardware.
Right.
And obviously they go into different roads. Okay? And it's much easier for the software to evaluate it and test it in a separate computer or computer system, and then integrate it in the product at the end. And then the product kind of flows with kind of a dummy software to test the mechanical part and the physical part. And then you put those together. Usually, you may have the software, you don't have the hardware yet ready to test things, so you have to do it separate. So when you plan, when the project engineers do the plan, they say, okay, let's separate these two things. It's more like a team effort between design engineers and process engineers, or I mean, project engineers. But yeah, service is applied for. I mean, this process can be applied for service.
Okay, great. Thank you very much, Oscar.
Sure.
Or maybe another question, Oscar. Which one of these categories is the most expensive?
It's typically development because it's where you have now physical things, but design could be, depending on the design, is where usually you have the most expensive people. But also depending on the materials, you may have not that expensive people, but very expensive materials.
Okay.
And then, but those two, I mean, the combination of design and development be the most expensive. Or pre-production, or let's say development. Let's say that we want to build 10,000 prototypes. Oh, it's expensive because okay, you have to do all that. So, but in general, let's say in kind of the common terms, design is could be the most expensive, or development the most expensive, or the combination of the two.
Gracias, Oscar.
Sure.
Oscar, question.
Yes, sir.
When you build in Ampex,
Yeah.
the product for the Olympics, 1980 Olympics in Russia,
Yeah.
did you provide service to those products or not?
No, actually, we're not permission to do that. I remember that the U.S. government didn't allow the machines to go to get to Russia initially. So basically, what we had to do was we had to train some people, including Russians, in California for them to do the service. It was very obscure because actually we never know exactly how they did it. Okay, they had all the documentation, we trained them, all that kind of stuff. But that was a very special thing. Okay, it still was the Cold War. I mean, it was crazy, and I don't know. I don't remember. It was many machines.
You're right.
Yeah.
Thank you.
Yeah, welcome.
Yeah. Oscar, let me ask you a question.
Yes, sir.
You've been working in several companies already.
Yeah.
And one thing that is important is the management style.
Yeah.
Obviously, the steps that you described could be the same, but the management style could help or could be, something blocking the whole process. Which management style did you like most in your experience?
A very tough question. I mean, I have managed, for instance, at one time several development teams or design teams in the world, and sometimes you face details that you don't understand the culture of that country, and you make mistakes. And I did some mistakes by combining to the same level Indians and British. Okay, never done that. The other thing is, let's say I think Mexico, one characteristic there is everybody's Mexican. Okay? Same culture, same thing. And then you can improve your style because it's a lot of commonality in all the people. And when I started with the first design teams in Juarez, it was great because everybody was kind of the same culture. And obviously, the idea when I did Ampex, actually, I started in Juarez and then moved to Colorado, to Redwood City, California, and then we started growing the design team there. And I had some part in Mexico, part in the United States. And I started integrating myself into the design team that already was there. Actually, we were very young, and the design team was there, were very quite old. So actually, they were very pleased that we were replacing them. So, but again, it was very interesting because you had to understand the culture first in order to create a good environment and good, how may I say, incentive for the people. And for me, for instance, that good environment with people from Mexico, from Juarez, was great. Okay, everybody was anxious to go out and learn things and do things and design. And the other thing is how you balance this team, because you don't want to have that. So everybody knows about this thing, but nobody knows about this other thing, or everybody likes to do this thing, so you have nobody to do this thing. Okay. So, for instance, what I did in Juarez is to so here's a whole bunch of people that come from, some of them were just out of the school. Some already have some people working in the team and the test team, that was good. And I started picking people from there. So I picked some of the good, best people I have in that were there. So everybody was in the same level. Most of them were the electronic engineers, but we had to do electronics, mechanics, thermal analysis, cosmetics, etc. So what I did in some way, I kind of started asking everybody, looking for their main vocation, and say, okay, guys, what do you like from this thing? And then I found that everybody liked the same thing. They want to be with the circuits doing things. So, okay, you're gonna go here and you're gonna study let's say mechanical design for, and I was with amplifiers, and then you go here and you're gonna design magnetic components, okay, transformers, switching magnetics, etc. And then the guy said, oh, I don't know what's that. Okay, so you go there. Well, I found that everybody liked what they learned. I got another guy that said, okay, you're gonna learn about PC boards. That's your work. Okay, you learn how to design PC boards. Go where the main courses and seminars you find in the world. And yes, he went and find a great teacher. Even that guy that wrote a book on PC boards. So anyway, so everybody that came back from that was kind of say, yeah, I like that. Okay. And I started with a team that was very balanced. So the problem is when you have unbalanced teams. And this could be because of technical reasons, could be because of cultural reasons, or could be because psychological reasons. Okay? Some people, a design team, you have to have a lot of integration, okay, among them, and it's very difficult. Some people don't like that, and you have to identify them, and you better take that person out before you contaminate the other people. So in that way, you keep a more harmony, okay, in the work of the people. And yeah, sometimes I have to do that. And like I mentioned, one time I moved an engineer from England reporting to an Indian manager in India. And everybody told me that's the biggest mistake I could have. There's no way you can have a British guy report to an Indian guy. And I made that mistake, and the poor guy, the British guy, that he was doing his thing because that was his culture. And I learned that, but I had to fire him because all the team were Indians. I said, okay. So anyway, you learn that. Sometimes you have this kind of hard stuff. Now, design teams are different, I may say, than any other team because, like I said, they are working for the same baby. Okay, that doesn't exist, and they have to have all this kind of qualities of critical thinking, and then empathy, and everything of the human qualities, and you have to learn how to identify that. And the main thing is that you something you inherit, because I inherit some design teams in the world, and there's some California where you have Russians and Americans and Mexicans and Chinese, and I said, okay, how do you deal with all these guys? And then how you understand each of them? It was very difficult. Like I said, Mexico, I had no problem. Everybody was about the same, a repetition of the same, but over there, not. And then people get something very, very, very mad and start swearing and saying. I remember in Redwood, in California, in San Jose, with the lab, there is a sign that said bad words only in your native language. Okay? Not English, because you start offending the other people. So again, yeah, managing, especially this type of teams, is that okay? You need to have some harmony, because it's not something that I do this and pass this to here. Sometimes it's a process, okay, that is very well defined, okay. Sometimes this guy is in a good mood, this guy is in another good mood, okay, and the two guys are do very good things. But if you don't create that environment, that chemistry never may happen, okay. So it's very complicated. You're dealing with very, like in every area, different people, but in this case, it's very special, different people. Okay? Sometimes
Right.
just nerves. Okay, that's and you have to yeah. Obviously, I mean, how you learn to do that? Okay, some is intuition, some is because okay you have some abilities to do that, and some things like everything is making it.
Yeah.
Because that's something.
But if you,
Yeah.
Oscar, but if you compare for a second, the management style from IBM, Hewlett Packard, and corporations like that, did you notice the difference in the management style back in those days?
Yeah. I was, I mean, had the chance to test IBM. The IBM environment was very formal. You go to meetings like Men in Black, okay, every with the same suit, tie, and all that stuff, okay, very formal. Everything, procedures for everything. There were practically no way that you can deviate anything. Everything that was done before was perfect. Don't move it. If there is a mistake, it's your mistake, not the system. Not so. In California, even in MPEX, what was the hippie time, okay, everyone has freedom to do everything. There were no kind of restriction. It was like a very loose people. I mean, a lot of freedom to do things. And that also is a big difference between Northern California, Silicon Valley, and like Southern California. Like I work also part Universal Electronics that was in Southern California, in the LA area. And that was more kind of a combination of various sections of the United States. But the Silicon Valley people was completely special. Okay, it was different. One thing that happened in Silicon Valley is what happened in something that somebody wrote a book that is where ideas come from. And Silicon Valley was started pretty much in San Francisco, but actually San Francisco was doing nothing, okay? Everything was like before South San Francisco and before San Jose. Even San Jose was not there. So it was that area. And from San Carlos to, I would say, Sunnyvale, pretty much. So anyway, the idea is that we get together in the cafes and everything. Everybody started talking. When you got into a very crowded restaurant and was one empty seat, and you say, oh, guys, can I sit here? Yeah, sure. And then you find that one guy from HP, the other was from Intel, and then you start talking. And you start distributing information. Okay. So there was no way that you will do that in Armonk, New York. No way. And you have strictly prohibited to do that.
Yeah.
So it's all the spectrum. And India, for example, is you have to describe the Indians, okay? Because Indians are very good because the way they are formed, they grow is that they learn very easy, very early to meditate. Okay, they have a huge capacity to concentrate in something, and they can go from point A, point B, perfect. The problem with India, and sometimes I almost get killed there, they have no imagination. Okay?
Mm-hmm.
They have no creativity.
Okay.
Now, Mexicans, for instance, they have a lot of creativity, but they're not organized. Okay, they are not. They don't follow a team okay. So the Mexicans work very well individually, not in teams. Indians, they work in teams, but they also kind of isolated from each other because they get very concentrated what they are doing. And I have some problems sometimes to integrate meetings with them because they haven't talked for the project in a long time. I'm among them. But they know where the other was. So I say, okay, how do you do that? Yes, you have telepathy or something like that. No, we know that. But anyway, so it's the geography, it's the cultures, well, everything, okay? The Europeans, sometimes it's tough to describe. I work in the Netherlands with Philips, okay? And this guy was pretty much like the Armonk in New York, okay? Very, very, I think, educated, very professional, okay? Yes, they were kind of sociable, but not that much. So I may say very cold environment. And then you think that all Europeans say, no, they don't like each other. Okay? The people from the Netherlands, they don't like the people from Northern Europe. They don't like the French. Okay. And sometimes they told me, Oscar, I don't understand you guys in America. Here in Europe, all of us are enemies, and we got together. You guys in America are supposed to be friends, and you're not been able to get together. But anyway, that describes that environment, and you see big difference between the French and the Spanish. Spain, I didn't have a chance to work there, but I know some of them. We are pretty much like them. But the French and the Italians, it's a mess. It's nice. They're good. They're good. I was one time we designed a amplifier for. It was here in Juarez, an amplifier for Alpine, the Alpine the audio company that make equipment for cars. And they're supposed to be the best in the world. And they're from Japan, and they have an office in California. And they were working on a promotion with Lamborghini in Italy, okay, from one of the cars. And the idea is that this car is going to have this amplifier that we were designing in Juarez. Okay? And the amplifier was perfect. Actually, we convinced the people from Japan because actually the Japanese were not able to get into the U.S. market in the audio, the car audio, but didn't know why. And the good thing, I have very good people in audio, okay, from Ampex, that when I proposed to them the problem, when I showed them the problem, yeah, a lot of ideas. And yes, we made it. Okay? And then they started testing. They called me, say, Oscar, this is great. And that amplifier was the best seller 3 years in the United States, consecutively 3 years. So anyway, it has that popularity that Alpine and Lamborghini decided to put it in the car. Okay, and yeah, we send the sample of the unit, and then they call us, say, okay, your amplifier doesn't fit. What do you mean it doesn't fit? Yeah, the mechanical position of the hose is wrong. And I don't know if he's laughing or crying, but anyway, I went to Italy, okay, and I went to Lamborghini factory. And then they received me, and they were not very friendly. Because what you did? So, yeah, tell me to where is it or the problem is. So they took me, and they didn't have the full car. They had like the back of the car because they had to make a special arrangement to mount the amplifier because Lamborghini, those cars, the whole car is a motor. There's no space for anything else. And the guy said, look, he put the amplifier, and these 2 holes line, but these other 2 didn't line. Huh? So I measured that. I measured the spec. I said, why? It's exactly the print. I said, what print? Here is you created this thing. Oh, I had measured that. You know, the thing was made by hand with hammer. And the guy, when the external part, not where the amplifier was mounted, was okay for him, say, okay, this is ready to be mounted. So the thing was not right. So I said, sorry, but the amplifier is fine, but your thing is not. So I learned that the Lamborghini were made by hand. The door they were hammering, they were closed. That was the style, anyway. And so again, it's I guess I have a very good design team in Juarez. Started in Juarez. Most of them actually were transferred or moved to US. Most of them are in the US right now. And but I feel that was pretty much the best team I created. But again, because it was my culture, okay, I was most able to have a management style that I could apply to them, and because I knew the culture. And I started having a lot of problems when I started dealing with a multi-race people. And especially like in Asia, okay? The US can, most of the people in US tend to kind of mix in the same culture, American culture, okay? But still, they are very much like their own culture. And yes, I have a lot of problems and deal with Russian engineers. Very smart guys, but very difficult to deal with them. And I had those Chinese, other Europeans, other Americans, put a lot of people from Stanford. But anyway, you never know if that guy will be Italian or German or whatever. So yes, it's very difficult to say what's the best management style for a design team. I think it's an art. You have to apply this, go to a feasibility of doing this thing, okay, and test, create prototypes in some way, start working with them until you see how they move, how they work. And from there, but obviously you need a product to do that. Okay? So you have to put attention to that first time that you start playing with this team, and start working accordingly with each of them. Just be like their father, okay, for one of them, and also try to conciliate between people fighting or people not agreeing on things. But at the end, you kind of settle down the team, and it takes time. It takes time to create a good team. And what I found in the United States, there were teams that used to be working together for, I don't know, 20 years, 30 years. So they were very, very, how can I say, integrated, okay, and very professional. No, well, professional, all of them were. But that's why also, these people I'm referring to is more in California, okay? That's why they created, I mean, things that nobody else in the world created. All that area in Silicon Valley was incredible. In Ampex, the company I used to work for, what was the largest in Silicon Valley? We had 25 buildings there. Intel was studying, Hewlett Packard was kind of big, but not as big as us. But I found these teams in Hewlett Packard, for instance, with the same thing, okay? And AMD and Intel, all the semiconductors companies there. And I know the people because we kind of go and have lunch together. Okay, it was great. It was a great environment, and I think this type of environment that will make that thing grow the way it happened. And maybe the same now. It's not different. So yeah, that's it takes time. It's good. Sometimes integrate integrate a design team. You have the technical expertise, and then the next thing how you deal with the humans, okay? How you work with them, let to know them in the way that they can work in harmony, okay? Understand people. Sometimes you have to take a decision that will not fit there. And sometimes it's better to change it, move it out, or just otherwise, yeah, you will never select a stable team. That's weird. That happens. Yeah. I don't know if there's any other question.
Thank you, Oscar.
Any other question from the group?
No.
Well, thank you.
Thank you, Oscar.
No, thank you, Oscar. You know, I think we can spend hours and hours talking with you about your experience, and it's not going to be possible to finish.
We're going to invite you to play football, soccer, Oscar.
You meant in the table? I haven't played football, soccer in many years. I don't know. I don't know if I survive.
But you can try to play golf with us, you know.
Yeah, golf,
Hector
yes.
play golf.
Yeah, maybe golf,
Okay.
yes. I can afford to hit a ball and know what happens. Try to see what happens.
Oh, thank you so much. Oscar. You
Oh, you're
know,
welcome. I had at the beginning when we started talking about that. I remember we were supposed to talk about the microcontrollers, the semiconductor microcontrollers, and maybe we could do another. I have that. I have that.
yeah,
This is the semiconductor process
Yes,
qualification
Oscar.
procedure. No, this is huge. Okay, this is
yeah.
this first part is the development, and
In-
here is the manufacturing. Okay, manufacturing is very complex, very expensive. I work in design. I knew the manufacturing. Okay, I never worked in the manufacturing side of the fabs. We have our fabs in Idaho, and I used to go there because I designed the microcontrollers here in San Jose, and then and kind of know these things. So I started compiling all this information. Uh, it's extremely expensive, extremely complex process. But I did pretty much the same as the other. I tried to put an outline, and then I learned the process, and then it's sections, okay, for every one of those. This tool I'm using is called HydroMind. I put it here in the, where is the chat? This one here? No. I think it's not allowing me. Let me. Well, chat's supposed to be here. Oh, here. Yes, it is. So, is company is Wondershare. Oops. Hydro.
Don't worry, Oscar. Later.
Okay.
Yeah, later. Yeah. Oscar, I'd like to take a conversation with you, in another time in reference to one of the topics that you mentioned here in your experience, says develop telemedicine systems to enhance remote healthcare capabilities. That
Yeah.
sounds interesting. I'd like to talk with you later.
Yeah, I can show you some of the equipment that we're working now with the Mexican government, and very well. But we are working also like in all Latin America with different countries. It's very new, and people is kind of scared. Okay, but yeah, we can talk about that.
Okay.
It's great for
Well,
schools.
excellent.
Okay.
Jack,
Yes, sir.
so how do we are with the timing? Is time to close the presentation or?
I think it
Oh, yeah.
is. Thank you, Oscar. I think it was a very good presentation.
Thank you.
And I will work on the video to get it posted to my ASQ and to LinkedIn and get that completed.
Okay.
All right.
Thank you, Oscar.
Thank you, guys.
Thank you.
Thank you again.
Thank you, Oscar, very much.
See you guys later. Thank you.
See you.
All right.
Bye.
Bye now.
Bye-bye.
Bye.